Good morning class, I am Govind Vyas. As you know, in the last lecture, we studied about theorem 10.1 of chapter Locus. Today, we are going to start the exercise 10.1. Okay. So, the first question in the exercise is about true false. Some concepts we studied so far. Right now, we are going to do some true false types of question regarding those concepts. Fine. So there are long statements given in the book. So you have book in your hand. I would like that you read the statements here. I'm not gonna write the statement. I'm just gonna explain and then solve for you. Okay. So the first true false says the set of points equidistant from the given line is also a line. Firstly, there is a line. In the first true false, a line is given. We are said that there is a line. Okay. Now, what does it say? The set of points equidistant from these lines. It says there are so many points. How they are arranged? They are not arranged randomly. All those points are at equal distance from this line. Clear? So, suppose that I am taking any particular point on this line, a point from this line at certain distance, like they take this as for understanding 5 centimeter away from this line. Okay. Now I am moving here. Now I am to find another point at equal distance, because it says equidistant. This point I placed at 5 centimeter away. Now from here I will put another point at 5 centimeter away as well. Okay, because the first statement said us that there are the set of points, means there are lots of points, and what about them? They are equidistant from the line, means how many points I plot here, all the points must be at equal distance from the line. Okay, so another point I am taking, will also be at 5 centimeter distance. Another point I am taking, it must also be at 5 centimeter distance. This is what the question said, that put lots of points and all those points must be at equal distance from the line. Okay, so you can see this can be said to be 5 centimeter, 5 centimeter, 5 centimeter and 5 centimeter. Basically it means all the points must be at equal distance from the line. This is what we have done. Now join all the points. I have joined all the points. When I joined all the points, I have drawn it without any scale or ruler, because this is not required right now, but I would like that you solve it in a very good and neat and clean diagram. Okay, so when I join all the points, what did I get? I got a parallel line. You must understand the meaning of parallel lines. Those lines which always walk together but they never met, like railway track, right? Railway track is a very good example of parallel line. So we also got here parallel lines. So what did we get? We got a parallel line. We had a line, and from these set of points, by joining these set of points, these all points, we got a parallel line. So let's see what the question says. The question says the set of points equidistant from the given line is also a line. It says this must also be a line. Yes, this is a line, but the correct answer is parallel line, because it says only line. The question says if you connect all the points, you will get a line. The line can also be like this, an inclined line, right? Something like this. If the question could have said us that the line obtained is a parallel line, it could be true, but it said just the line. Line can be like this, something like any kind of line, but the correct answer is the obtained line will be a parallel line. So the statement is false, because if the statement was something like this, if you plot all the points the line you will obtain, the line which you obtain will be a parallel line, then it could be true, but it did not mention the word parallel. That word is missing. So the first statement is false. And what is the reason? Because in heading it is said that justify your answer, means if the statement is false, we have to give our reason that why is it false. Because it is, I am explaining you, you will write it is false because the obtained line is a parallel line. Only line means it can be intersecting something slant line, right, inclined line. The correct answer is parallel line. Fine. So this is our first portion of true false. Now we are moving for the second one. What is the second one? A circle is a locus of the points which are equidistant from the certain point. Okay. First, it is said that draw a certain point, any one point. So we are doing second portion of true false. Any point, any certain point. Now what does it say? Draw a equidistant point, equidistant point. So okay, we have drawn lots of equidistant point from this point. Take this is 7 centimeter. Okay. So this point is 7 centimeter. Again this is 7 centimeter. Again this is 7 centimeter. Again this is 7 centimeter. Why I am drawing all the points at equal distance? Because this is what the question says. All the points are equidistant from the certain point. This is the certain point. This is the any fixed point. These all points must be at equal distance from this particular point. So okay. So I am assuming the distance of 7 centimeter. Again this is the same distance, same distance, same distance. All the points are at equal distance. Now what? If I join all the points, okay, let's join this. Okay, I am drawing it with a rough freehand. Okay, if we join all the points, we get a circle, right? And what figure the question our question mentioned? It also mentioned it will form a circle. I am reading it for you again. A circle is a locus of the points. These were the points. We got a circle which are equidistant from a certain point. All these points which are forming a circle are at equal distance from this point, right? We are seeing it here, and same thing we are reading in the book. Both things are matching. So that means this question is this statement is true, right? So second one is true. I hope you got it, right? Fine. So this was the second true false. Now we are moving for the third one. It says 3 points are collinear only when they are not the elements of the set of points of a line. Very easy. There are 3 points. We are doing now third portion of true false. 3 points. First point, second point, and third point. These are the 3 points. 1, 2, 3. If I join all the points, okay, let's join them. Wait. Why did I draw the points in the proper manner? I could have drawn these like this. First point is here, second point is here, third point is here. This is first, this is second, this is third. Why did I not draw something like this? I drew it like 1, 2, 3. All the points in the same plane. Why did I draw like this? Because there is a word mentioned in the book. What word? Collinear. Collinear is mentioned there. Collinear means on the same plane, on the same straight line. So that is why these are drawn at the same line. So when I connect them, what does I get? What do I get? I get a straight line, a linear line, right? I get a straight line. And what does the question says? When they are not the elements of the set of points of a line. Basically, the language of the question says, if we draw three collinear points and join them, then the thing we obtain is not a line, Basically this is what the question says. But when you see here, when I joined all these 3 points, this is a line, right? And the question says this is not a line. So both things are not matching. It says when you join the 3 points, collinear points, this will not be a line, but this is a line. You see this. So this statement is false, because we are obtaining a line. So what reason will you give? You will say when we join all the 3 collinear points and by joining them, we get a straight line, right? Collinear points always form a straight line. So this statement was false. Anyways, now we are moving for the fourth true false. The locus of the points equidistant from two lines will be a parallel line. Fine. Okay, let's do this. Question number 4 we are doing now. So fourth portion says the locus of the points equidistant from two lines will be a parallel lines. Okay, firstly there are 2 lines. Okay, this is a line and this is a line. Okay, so these lines are given. Now their locus means we have to put some points which are at equal distance from both the lines. Okay, this can be one point equal distance from both the lines, another point equal distance, another point, and so on. If I join all the points, what did I get? I get another third line which is parallel to this and this as well. According to this particular condition, this statement is true. There were 2 lines, these. According to this condition, this statement is true that the third obtained line will also be a parallel line. But notice one thing, I drew this line and this line already parallel. I drew both the lines parallel. It was not given in the question that I have to draw parallel lines. It said only 2 lines, not 2 parallel lines, right? It said only 2 lines. So this means I can draw the 2 lines like this also. First line is like this, second line is like this, because it is not mentioned here that how they are arranged, like this, like this, like this, how they are arranged. We can draw in any manner. So if I draw them like this, then what will be locus? From this and from this is equal distance, this is equal distance, this is equal distance, this is the equal distance. And if I join them, the obtained line is not parallel line, which the question said that it is a parallel line. This is not a parallel line. So if these 2 lines, the given 2 lines are not parallel, this can never be parallel, right? So if the question mentioned that there are 2 lines which are parallel, then the statement could be true, but the parallel word is not mentioned for these 2 lines. It is mentioned just for these lines. So in this case, the statement is false. Again, you have to write the reason. What reason will you write? That the third line can be parallel only if the other 2 lines were parallel. The middle line can only be parallel if the given lines, these 2 were parallel, right? If these 2 lines are not parallel, this cannot be parallel, right? So this is false statement. Our final true false. Let's see. The locus of a point equidistant from 2 given points. The perpendicular bisector of the line joining the 2 points. Very easy. We have done it so many times. It says there are 2 points. Fifth part. First point, second point. Join these points. I have given them name A, B. We did a theorem also regarding this, and also in the first lecture we studied about this. Okay, so this is not very difficult now. So we have to find the locus. How will we find this? Any point at equal distance from both these points. It is a point equal distance from here, Another point equal distance from here and here as well. We have studied this so many times, so I am doing it very fast. Another point equal distance from here and from here. So lots of points can be something like this. And if I join all the points, I get a line which is 90 degree here. So this is perpendicular, and suppose this was of something length, then now after this line, this is half, it is divided into two equal parts, perpendicular and bisector. So yes, it is a perpendicular bisector. That is means the statement and the figure matches together. The statement is true. This is a true statement. Okay, so this is the way we solved our true false question number 1 of the exercise 10.1. If you are having any doubt regarding them or regarding anything we have studied so far, you can contact us. Okay, till then, like this channel, share and subscribe. Thank you.